Hi folks, this is a couple of examples about z-scores. The formula is there, z is equal to x minus mu over the standard deviation. The mean is always the mu, so in this example the mu is 210 and the standard deviation is the 20. We're asked to find out the probability that a bulb selected at random will last more than 240 hours. So that's the probability that x is greater than 240. That's what we're working out. We have to work out a z-score for 240 first of all. So if I write down my formula, z is equal to x minus mu over the standard deviation. Even if you can fill in this much, you'll get some marks. So the x is always the thing that you're asked about. So in this case, it's 240. So 240 minus mu, we know, is the 210. That's always the mean or the average. And then the standard deviation is 20 in this one. So our z-score will be, our z-score for 240, if you put that into the calculator, is 1.5. That's our z-score for this. So because it's finding out that the probability is greater than 240, we're finding the probability that our z-score is greater than 240. And when it's greater than, we need to know that you do 1 minus, okay? So we're going to do 1 minus the probability that z is less than or equal to 240. Or sorry, not, the 1.5. So our z-score is 1.5. So you'll go to your tables then and you look up 1.5 in the z-score tables and we should get 0.9332. So 1 minus, and then it's 0.0668. That's the probability. So when it's a greater than, or if it's a minus, if that was a minus in there, if either one of those, you do 1 minus. So second part is the probability that, so find the probability that the bulb will last less than or equal to 200 hours. So this is part 2. So we have to find the probability that x is less than or equal to 200 hours. Again, we're just going to do our formula. So z is equal to x minus mu over the standard deviation. So that's going to be 200, take away, mu was 210, and the standard deviation is 20. So this will give us our z-score. That's minus 0.5. Then we're finding out then that the probability of that z is less than or equal to minus 0.5. If we were to look at it on the actual diagram, so the normal distribution diagram, so the mean is in the middle, and then the further away from the standard from the mean it is, so in this case it's minus 0.5. So if that was 1, 2, 3 standard deviations away, our z-score is about here. It's minus 0.5. So we're trying to find the this area here. Therefore, we have to do 1 take away the 0.5. So when it's a minus number, like I said before, we do 1 minus. 1 minus the probability that z is less than or equal to 0.5. So that's 1 minus, you just have to look up your 0.5 in the z tables. 0.6915. And then that's 0.3085. And that's the answer. So next one, if you want to try this one yourself, you can. If you want to pause the video. Right, so the chest measurements of teenage male customers for t-shirts may be modeled by the normal distribution. So the mean is 101, so therefore our mu is 101, and our standard deviation is 5. And they're the first things we're always looking for. Find the probability that you'll have a chest measurement which is less than 103. So for our first part, it's the probability that x is less than 103. So let's get a z-score anyway. Z is equal to, it'll be 103, the thing we're being asked about. Take away mu, which is 101, over the standard deviation, which is 5. So our z-score is 0.4. We're trying to find the probability that our z is less than 0.4. So we just have to, yeah, this is simple enough one. We just have to straight away look up our z-score table. So probability that z is less than 0.4, that's 0.6554. It'll come up in that. So when it's less than, and when it's a positive number, we don't do 1 minus. That's just a normal one. So if that was a minus 0.4, we'd do 1 minus. Or if it was a greater than sign in the middle, we'd do 1 minus. The next one then, it's 98 centimeters or more. So that's greater than 98 centimeters. So we're finding the probability that x is greater than 98. So we have to do our z-score. Z is equal to 98 minus 101 over 5. That gives us minus 0.6. So our z-score is minus 0.6. We then have to find the probability that z is greater than minus 0.6, because it was greater than 98 was what we wanted. So probability that z is greater than minus 0.6. So remember when I said before that if it was a greater than sign, which we have here, or if it was a minus sign in it, which we have here as well, you would do 1 minus. Therefore, for this one, you'll be doing 1 minus, yeah, it's 1 minus 1 minus the probability that z is less than 0.6. So the 1 minus 1 minus, that'll just cancel out. So it'll give us 0.7257 in the end, whichever way you do it. So well, you just have to look up 0.6 in the z-score tables. Right, the last one is between 95 and 100. So third one, probability uh, that x is between 95 and 100. So really we're being asked about 100 and we're being asked about 95 in this one. So we're going to get two different z-scores. So I'm going to get a z-score with 100, take away our mean was 101, and then I'm going to get a z-score with 95. And we're going to take one away from the other in the end. So we get minus 0.2 and we get 1.2 as our two z-scores. So the probability that z is less than minus 0.2, and then the probability that z is less than 1.2. and they're both actually minuses here. So in each case, we'll have to do one minus probability that Z is less than 0.2, and we'll have to do one minus probability that Z is less than 1.2. And we'll get two answers there, and then we'll just subtract one from the other. So in the end, it's 0.8849, take away 0.5793, and we get a final answer then of 0.3056.